Okay.
Recording in progress.
To ensure that we stick to our schedule,
The share screen is still disabled.
now you can share screen.
SMO, all of which had AUC of 0.97, 0.96, 0.95, and 0.91 respectively. Yet, DT's AUC value of 0.77 indicates that it is the classification method that yielded the worst results. For conclusion, the findings demonstrated that 5 machine algorithms such as random forest, naive Bayes, logistic regression, Bayesian appropriate model of ADR and why the predictions can be improved with more data or more model development effort. This demonstration suggests eventually employing an early alert of the most severe case that can inform clinical treatment decisions. Thank you for your attention. ขอบคุณค่ะ
Thank you, Ms. Sophie-Sitipan, for the presentation. Now we have to the Q&A session. Please raise your hand or write your question in the chat room. If you have a question or comment for the online participant. Is there any questions from the participants? You can ask the question directly to Ms. Sophie-Sitipan by raise your hand, or you can write the question on the chat room. Okay, maybe I will start first, yeah, to give a question to Ms. Sophie-Sitipan. Okay, so from the conclusions, you said that the 5 machine learning algorithm that you have used in your research are appropriate models for estimating the seriousness of ADRs in patients. Meanwhile, decision tree performed poorly as a classification algorithm. According to your literature review and results, why is decision tree doesn't work well for your data?
Thank you for your question. In my opinion, I think my data is a big data and very complicated. So decision tree is a simple, it's not enough for analysis for big data and complicated data.
Yeah, so decision tree have a limited for big data, yeah?
Yes.
Okay, thank you so much for your answer. Now I will back to the participant. Do you have any question to Ms. Sophie? You can raise your hand or write your question on the chat room. Okay. If there is no one participant who want to ask to our presenter, Now, thank you for Ms. Sophie Sitepan for present your work. And you can close your share screen now, so we can go to the next presenter. Thank you so much.
Thank you so much, terima kasih.
Sama-sama. Okay. Okay, now our next speakers or our presenters is Ms. Ulfi Widya Astuti from Institut Teknologi 10 November, Surabaya, Indonesia, who will be presenting on classification of sweet and sour taste using electroencephalography or EEG. So Ms. Ulfi, you can share screen and start your presentation now. Thank you.
Hello.
Oh, yes. Oh, I'm sorry. I'm so sorry. Thank you. Our next presenter is Miss Hiba from Al Bahrain University, Iraq. Yeah. Thank you for reminding me. So, Miss Hiba will be presenting on breast cancer classification in ultrasound image based on deep neural network models. For Miss Hiba, time is yours. Thank you.
I am starting.
Yeah.
Hello, my name is Hibadia Al-Rubai. The title of my search, breast cancer classification in ultrasound images based on deep neural networks models. Introduction. Breast malignancy is the main reason for death in females and the greatest prevalent cancer in general. The ultrasound method is frequently working in the detection of a breast tumor because of its suitability and painless method and effective real-time performance. However, in contrast to other widely used methods like mammography, breast malignancy diagnosis based on ultrasound images frequently requires skilled medical professionals. Deep learning is a part of machine learning that implements self-learning algorithms named artificial neural networks, ANNs, that are stimulated by the construction and function of the brain. The aim of my research, these models could be a viable solution for Iraq challenging the clinic environment, consider the lack of medical study and identification possibilities. This model was created to assist the radiologist in the analysis procedure and to raise the number of patients receiving medical care by diminishing the time expended on breast images. Methodology. Number one, collect data. Number one, data set, pre-processing, resize, normalization, augmentation. Three, CNN, VG-Josephage, classification, benign, malignant, normal. Dataset. I used the dataset free breast ultrasound image data used in this work. The dataset includes 718 images with a mean image size of 500 pixels by 500 pixels. The dataset is in PNG format. The original images are shown with ground truth images. They were classification into three classes, namely benign, malignant, and normal. Pre-processing. Pre-processing in image processing, number one, I make two images resizing. It's used to adjust the number of pixels used to display an image. Number two, augmentation images were used to obtain the best result by rotating left, rotating right, flipping vertically, and flipping horizontally. Normalization ensuring that all variance values were between 0 and 1 by dividing the original data by 215.5. Normalization may be quite useful for forecasting. Normalization is extremely advantageous for neural networks-based classification techniques. Feature extraction. The CNN and transfer learning VG16 model was used to extract features from ultrasound images to classify breast cancer for this investigation CNN. CNN models. CNN model input image used for convolutional layer and this is for convolutional layer we have feature extraction and two dense used to classification and prediction. VG16 model. VG16 model مكون input image 13 convolutional layer used to feature extraction and 3 dense layer used to classification and prediction. Result. The CNN-based model, when using achieved an accuracy of 19.6%, while the accuracy is 19.8% when VG16 was used. This confusion matrix of CNN and VG16. Result. This scheme model accuracy model loss. Trend and validation accuracy for VG16 and trend and validation loss for VG16. Conclusion: the breast cancer ranking model were established using the convolutional neural network and VG16 for feature extraction and classification. The dataset was 718 breast ultrasound images. The data augmentation method was used to obtain the best performance. The proposed model were trained on breast ultrasound image dataset to classify cancerous, non-cancerous, and normal images. The VG16 model provided the best classification accuracy from the CNN model. Thank you. Thank you.
Okay, thank you so much, Ms. Hiba, for your presentation. Now we are on the Q&A session. So for the participant who want to ask Ms. Hiba, you can raise your hand to ask the Ms. Hiba directly, or you can write the question on the chat room. Is there any question from the participant? Emang udah bodoh sih. Anyone who want to ask the question?
Ada.
Oh, okay. Miss Iba, I have a question from the chat room from our participant, from Miss Kirliani. She asked, how many image for input for training, testing, and validation? Thank you. You can answer that.
Spell the image 18 and 20. 700 700 718.
Maybe can you repeat the answer? How many image for input for training, testing, and validation?
One 120 for validation.
For validations, for training and testing?
Mm. 13 for training 13 30 318.
Okay. How Miss Kirliani, is your question answer well? Okay,
What?
thank you. Thank you. Is there any questions
Welcome.
for Miss Hiba? No one? You can raise your hand if you want to ask Miss Hiba directly, or you can chat them. Okay. We have one question from Sulistia
Yes.
Fahati from Shahpal University. She want to ask regarding the best classification. Is it only seen based on the value of data accuracy, or are there other criteria? Thank you.
Thank you. What? Not understand.
She asked, regarding the best classification, is it only seen based on the value of data accuracy, or are there other criteria to choose the best classification method?
The best classification?
Yes.
The best classification الفيديو 16 مود VGG 16 was the best classification from CNN.
Okay. Thank you. How, Miss Listia? I hope that answer your questions. Okay. Thank you, Miss Hiba, for your presentation and for answering the question from participants. Now you can stop your share screen so we can go to the next presenter. Thank you so much.
Thank you.
Okay. Okay, now we can go to the next presenter. Miss Ulfi Widya Astuti from Institut Teknologi 10 November, Surabaya, Indonesia, who will be presenting on classification of sweet and sour taste using electroencephalography. Or Miss Ulfi, the screen is yours. Thank you. It's Miss Hiba, can you stop the share screen?
Yes.
Can you stop the
With
share
res-
screen? Okay, thank you. Now to Miss Ulfi, you can share your screen and start your presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you. Good morning, everyone. First of all, I will say thank you very much for the opportunity to join this international conference, ICMSA 2023. Let me introduce myself. My name is Ulfi, and I am master degree student in electrical engineering at Surabaya. So today we will present about our research, and the topic of our research is classification of sweet and sour taste using electroencephalography EEG. Okay, ladies and gentlemen, let's go to the presentation. For survival, humans require food and drink as a source of nutrition for the body. After COVID-19 caused the global food price index to soar to 34% from 2020 and 2021, and the beginning of 2022, the world food price index was the highest. As a result, consumers are becoming increasingly selective when purchasing food and beverage, and the competition among food and beverage products is becoming more intense. Therefore, food and beverage companies must innovate to maintain the quality of their products. One of the qualities that make products survive in the market is taste. In our body, we have taste bud as a sensor of food and drink. Taste buds are the gateway to balance energy and nutrition in humans. Therefore, they are extremely important in criteria for selecting human food and for their health and survival. Information conveyed through the gustatory system helps in identifying nutrition and edible food, allowing humans to avoid hazardous substance and encourage the selection of food on nutrition content and personal preference. The perception of taste in food and beverage is influenced by various subjective factors such as hunger, appetite, health condition, past experience, individual preference, mood, and etc. Human taste perception is difficult to understand and requires more objective research to gain better insight into the mechanism involved. Broadly speaking, there are two ways to research human response to food flavor: explicit by questionnaire and implicit. Explicit response have some shortcomings, such as high subjectivity, and evaluation made after testing food or drinks cannot be done directly. Neuromarketing is scientific discipline that focus on non-invasive brain signal recording. Brain signal recording technique to directly measure customers' brain response to marketing stimuli, replacing the traditional survey methods. Research by placement discuss the advances and challenges in the field of neuromarketing and its potential for understanding consumer behavior. The authors state that there is still much to be learned in the field of neuromarketing. Electroencephalography or EEG, often referred as EEG, is a tool that records the electrical activity of the brain by attaching electrodes to the scalp. EEG has the advantage of being relatively cheap compared to the other methods of neuromarketing. In addition, EEG is easy to operate and has good temporal resolution, making it widely possible to use research related to brain response to the flavor of food and drink. The 5 basic tastes of food beverage are sweet, sour, salty, umami, bitter. Sweet and umami tastes determine availability of nutrition food, while salty determines sodium content in food that function to increase appetite and hunger. Meanwhile, sour and bitter tastes the considered unpleasant and function indicators of toxicity of toxic and harmful substance. Therefore, the gustatory system must make quick decision about whether the substance is safe or hazardous. The stimuli chosen in the study are sour and sweet taste. The sweet and sour taste and the most commonly found flavor in food and beverage consumed by people worldwide. But are two tastes that have very different characteristics from each other. The following for clear comparison. And then there have been several previous studies that have shown that the taste and can affect brain activity in areas related to attention, emotion, and language. While sweet has been associated with the activity area related to reward and motivation. The objective of this study is to evaluate the use of EEG in assessing preference of for sweet and sour taste and to compare EEG method with explicit method in evaluating human response to food taste. And then the problem statement in this study, we use sweet and sour taste as well as weather best as a baseline, and we use as stimuli. And then the EEG signal observation were conducted in the frequency band alpha, beta, gamma, delta, and theta using channel CB1, CB2, T3, and T4 to distinguish between happy and sweet and sour. And we use MFP, STD, and power PSD for the acceleration feature. The methodology, there are a data recording, reprocessing, feature extraction, classification, and data analysis. In the data recording, we select some participants to join our research, 32 health participants participate in this experiment. And then the EEG signal were recorded using the Ultra Cortex Mark IV headset. The OpenBC IC tone board was used for wireless communication between the hardware and the computer software. The EEG samples were taken at rate 2,256 Hz for the right electrode, CP1, CP2, 33, and T4 in the international 10 and 20 system. The EEG signal obtained were processed using MATLAB, and the signal were filtered using bandpass, automatic artifact removal, and independent component analysis. Then the signal was decomposed into 5 bands: delta, theta, alpha, beta, and gamma. Feature extraction, we use the domain time domain and frequency domain analysis. In the time domain, we use mean absolute value and standard deviation, and the frequency domain we use power supply density. Classification, we use KNN, STM, Random and crew. This is the step the data recording. This is the procedure when the EEG signal recording and the stimulus given to the participant. Each participant received 2 drinks with sweet and sour taste. In this study, we will attempt to investigate the difference in EEG signal response to the sweet and sour taste of the processed drink. Instead of using natural ingredient, we use to collect milk as the sweet taste and lemon juice as the sour taste. And then subject were interested to close their eyes. During the recording, participant drank the solution for 6 seconds. The recording process took place during the 6 seconds of drinking the stimulus solution. There were 2 stimulus solutions, chocolate milk and lemon juice, and water as the baseline. After each recording as a stimulus, participants were asked to fill out the questionnaire, and the questionnaire contained description of the taste and the solution. And then a liking scale, score 0, did not like at all, and 10 means extremely like. And the result from the questionnaire result is that participant described the taste and filled in liking scale. The result is from the test description column. All participants describe chocolate milk as sweet and lemon juice as sour. The average liking scores for sweet and sour taste are presented in the slide. The result is all participants more like sweet than sour. And then the first is mean absolute value extraction, and we saw that during this study we were able to extract each signal by separating them into brainwave band and channels utilizing features of MRV, PSD, and STD. As shown in this figure, we were able to identify notable difference in alpha and delta signals, where the MRV value for sweet stimuli was found to be higher than for sour stimuli in the alpha wave, and sour stimuli had higher MRV value than sweet stimuli in the delta wave band. Additionally, we discovered pattern in the theta, beta, and gamma wave band where channels CP1 and CP2 had higher value for source stimuli, where channels T3 and T4. And then for STD, our analysis revealed that difference between sweet and sour stimuli is particularly evident in beta and gamma wave band, especially in channels CP1 and CP2. Moreover, we found a notable difference in alpha wave band, particularly channels in T3 and T4. These findings suggest that the impact of sweet and sour stimuli on brainwave activity varies depending on the frequency. And then power spectral density, the PSD feature of sweet and sour stimuli exhibit a similar pattern to the MRV feature. However, the most striking difference between two stimuli is found in the alpha and delta bands. Sweet solution have higher PSD value than sour in alpha, and for delta, higher PSD. Let me present our classification stage finding. We employ four algorithms, namely KNN, SPM, random forest, and GRU, to classify the X-ray features. The result accuracy are shown in this slide. The GRU algorithm achieving the highest accuracy of 91.53%, followed by random forest, SVM, and KNN. Moreover, in figure classifier accuracy per feature illustrate that comparison accuracy for each feature. Our analysis revealed that the highest accuracy was obtained by PSD feature using the random forest algorithm, 91.49%. And then the second highest is by MRV feature in the random forest algorithm, resulting 89.98%. And our findings from our study is using edge signals from specific channels. Our method successfully identified the brain response to sweet and sour taste. Our result revealed the alpha and delta wave in the edge signal were particularly sensitive to sweet and sour taste. This wave served an observation point in the cortical layer of the brain when receiving stimulation from food or beverage taste. Furthermore, we found that the GRU algorithm had the best accuracy in classifying EG signal representing sweet and sour taste. This finding demonstrates the potential of using advanced machine learning algorithm to analyze EEG signals and evaluate as perception more objectively than traditional methods such as questionnaire. In conclusion, our study mechanism underlying test perception and offers of a promising approach to evaluate test perception objectively. I hope this finding spark your interest and inspire further research in this exciting field. Thank you very much for thank you.
Okay, thank you so much, Ms. Ulfi, for your presentation. Now we are on the Q&A session. So for the participant who want to ask Ms. Ulfi, you can ask directly by raise your hand, or you can write it on the chat room. Ms. Ulfi, we have a question from Mumtaz from Sheikh Kuala University. I want to ask, are there any limitation or challenges to using electroencephalography? Thank you.
The limitation from the EEG is we must know how to use EEG, and we must learn how to use EEG. And many studies learn about neuromarketing, but some 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 research focus in as like the stimuli in figure, but we focus on the classification of the test perception. And I think the limitation is we must learn the tools, the EEG first, and after that we can explore many channels or in the EEG for the test classification. And we can explore many tastes like umami and other tastes. So I think is more research we can explore in the test classification by using EEG. So
Okay, thank you so much for the answer. I hope that answer your question, yeah, Mumtaz. Okay, is there any question from participant to Miss Olvi? Okay, we have one more question from Norman Khalis from Shakwala University. He want to ask about when the participant was having the rest, were the participant given something to cleanse their taste buds? Thank you.
yes, the participant using water to clean the test buds. We recommend the participant to clean their mouth with the water 1 minute after one stimulate give to participant. I think.
Okay, thank you so much for your questions, for your answer. Are there any more questions from participant? Okay, if there is no question anymore, so we can close this presentation. Thank you, Ms. Ulpi, for your share screen, so we can go to the next presenter. Okay, so now we go to the next presenter. Our next presenter is Mr. Ahmad Mahruf Firman from Hasanuddin University, Indonesia, who will be presenting on performance analysis of face recognition using machine learning and modified deep learning methods. For Mr. Ahmad, now you can share your screen and start the presentation. Thank you.
Can you see my screen now?
Yes, we can see your slide.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished keynote speaker, members of ICMSA community, and all participants. It is an honor to be here to present my research at this prestigious 18th IMTGT International Conference on Mathematics, Statistics, and Their Applications, ICMSA 2023. My name is Ahmad Mahruf Firman, and my research paper is Fetal Performance Analysis of face recognition using machine learning and modified deep learning methods. Throughout my presentation, I will discuss my research introduction, methodology, results, and conclusions. And I hope to provide valuable insights and perspective on this topic, as I believe that collaboration and constructive discussion are essential for advancing in scientific research. The authors of this research, myself, as a postgraduate student, Ahmad Maruf Firman, and second author, my lecturer, as corresponding author, Dr. Insinyur Zainuddin, and third author, my lecturer as well, Dr. Engineering Insinyur Muhammad Miswar, and Infotech. I'm from Universitas Hasanuddin, Makassar. Introduction, face recognition has been a popular subject of study in computer vision for many years and is considered as a significant aspect of biometric technology in the identification process. Their applications can be seen across a variety of industries, including security, information, and transactions. A few techniques have been developed to improve the accuracy and the computation and efficiency of face recognition technology. This includes classical methods such as eigenface, feature face, and local binary pattern, as well as more recent deep learning-based approach such as convolutional neural network or CNNs. But there are still several challenges and limitations that research is working to overcome. Some of the key problems in face recognition include performance and situation are the main factors of the research results. For example, like intensity, pose variations, blur image, and also occlusion. But these problems is already solved by previous research or study and get a better result. So our main focusing problems in this research is second, large amount of data. Using machine learning and deep learning methods and on a large number of data sets will require a lot of computing time on training process and time breadth of real-time face recognition. So the purpose of this research, we have two purposes. First, methodology analysis, examining the effectiveness, efficiency, and relevance of particular methodology or set of methods used to accomplish a main goal of face recognition research with large volumes of data. This purpose can involve analyzing data, identifying strengths and weaknesses of the methodology, and making recommendation for future works or future studies. And our second purpose is algorithms modifying, optimizing the algorithm to get a faster training process and time rate of real-time face recognition with a larger data set, and to address any shortcomings that may have been identified during testing such as accuracy result. In this case, we employ a smart architectural model for deep learning methods during the training process. In addition to focusing on achieving high accuracy results, we also measure the time consumption for the training process. Steps in face recognition. In this study, we conducted two different experiments, two different methods for this research. First, we're using machine learning. As we can see, face recognition can be divided into multiple steps, which can be seen in the pipeline below. First, face detection. The first step in face recognition is to detect and locate faces in an image or video frame. After we get the face, after we detect the face, we have another process that pre-processing techniques are used to enhance the quality and accuracy of the input image and also to improve the robustness of the system. After we get a better result of the image, we're doing a feature extraction. In here, we extract the unique feature of the face and store them in the database. Finally, the system determines whether the face is a match to an existing identity in the database. This can be through a verification or classification process where the individual confirms the identity, where the system searches a database of known faces to find a match. In this experiment, we perform face detection using PhylogensSs or HR classifier method, and feature extraction using local binary pattern histogram, and classification using k nearest neighbor with Euclidean distance equation. Next, we also use deep learning CNN to extract and classification process. CNN architecture takes input in the form of images, which is deposited in the feature learning stage. The output of this stage is further processed in the classification until the final prediction. As we can see, the convolutional neural network architecture for face recognition typically consists several layers, each with its specific function in the overall process. the CNN layers. As you can see here, there's an input layer, convolutional layer, pooling layer, and fully connected layer, and also the final one is output layer. In here, output layer, the information whether the face is recognized or unrecognized. In our deep learning CNN purpose diagram, CNN is a kind of neural network where the input is an image. Our input is from real-time video frame, and after that we detect the face and normalization, some like machine learning. In our face detection, we're using hard cascade or intelligence and daily face detector, and normalizing image with resize and scaling, and then CNN training and face identification, which is classification problem. CNN architecture consists of two main parts. That is a feature learning or feature extraction and also classification. In here, our data collection, using webcam full HD positioned at a distance of 50 centimeters from face. We have 25 sample data per student, consisted 2,500 faces from 100 students. We can see their ID number of students and also their name. And for deep learning experiment, we also augmented to 50 sample data per student. And the facial image was captured using 1080p Full HD webcam. The resulting data was compiled into CBS face dataset collection and obtained at the Faculty of Engineering Universitas Hasanuddin. Our first experiment, we use local binary pattern histogram as a feature extractor and Canon with a Euclidean distance approach as a classifier. We can see here original image and LBP image. It shows that LBP and histogram values for each image in the training dataset, where each histogram represents an individual image. And then we got the result of training time local binary pattern histogram. We use a personal computer with Core i5 generation 12 and NVIDIA GTX 1660 Super and 16 gigabytes of memory. We get training time with 2,500 images, 91.24 seconds. And in order to measure performance of machine learning method, we conducted face recognition tests on 15 data here and obtained a real-time face recognition rate with average rate 0.87 seconds. And Euclidean distance approach successfully recognized 27 out of 31 testing data in the face recognition process and resulting in accuracy 57.1%. Our second experiment, we use deep learning CNN as a feature extractor and classifier. We have 2,500 images and 64 image dimension. We have, as we can see here, we have original image, resizing image, and grayscaling image. And during training, the CNN learns to extract relevant features from the input image and map them to the correct identity labels. We can see here factor 1 to 8D as labels of this image of this photo. And once the CNN is trained, it can be used for real-time face recognition by feeding with a new input image and using the trend classifier to predict the identity of the individual. We can see here recognized face as Muhammad. We get the result for training time. We performed two different another experiment with epoch 10 and epoch 20. For 2,500 image, we got epoch 10 51.65 seconds and epoch 20 we got 96 points. For the accuracy result, epoch 10 we got 92.71% and epoch 20 we got 94.15%. And our final experiment, our last experiment, still use deep learning CNN, but we augmented the data into 5,000 images and increased the image dimension into 128. We have another original image and resizing grayscaling image. We have another label data factor 1 to 8D and recognize face as Muhammad Kerlin. We can see overall this training time result for 5,000 images and image dimension 128. For epoch 10 we got 263.3 seconds and epoch 20 we got 532.72 seconds. For the average accuracy result for epoch 10, we got 96.5x 58%, and epoch 20 we get 98.27%. Overall, the computation time of deep learning based face recognition system can vary depending on several factors, and it's important to carefully consider trade-offs between accuracy, speed, computational times when designing and deploying such systems. So we can see that next phase in here, it shows the has undergone several previous steps. When a person is recognized by the system, their ID number here 17 and name will appear on the screen. So we can see in here 17 as Muhammad Ferlin. And our conclusion, through analysis and experimentation using various methods, phylogeny for face detection, locus for classification, and CNN deep learning for extraction and classification, we have three conclusions. First, larger data set is needed to improve the accuracy of face recognition using CNN deep learning method with immensely longer computation times. Second, adjustment were made to the architecture, number of neurons, image dimensions, and batch size of the CNN method to obtain better computation time results and accuracy. Third, face recognition can be improved by exploring a more larger data sets and further optimizing the CNN deep learning method by using advanced techniques such as transfer learning to also enhance the accuracy of face recognition systems. Thank you for the opportunity to present my research at this conference, and I look forward to engaging with all of you over the course of this event. And I finally also to express my appreciation to my lecturer as my professor for their dedication and hard work, Dr. Insinyur Zainuddin and Dr. Engineering Muhammad Miswar. Their contributions have been instrumental in the success of this research. Once again, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you, Mr. Ahmad, for your presentation. Now we are on the Q&A session. So for the participant who want to ask Mr. Ahmad, you can raise your hand to ask directly, or you can write it on the chat room. Is there any questions from the participant? Okay. Mr. Ahmad, we have one question from the chat room from Firliani. She asks, why you choose training time rate as a parameter to compare the results? Thank you. Mr. Ahmad?
Okay, thank you, Ms. Firliani Rahmatia. We use training time rate as a parameter for experiment using CNN deep learning because we imagine we have a project in our campus for using deep learning CNN. We imagine if next in the future works with 1,000 or maybe million of data, it's important to get the faster training result. If we have application, for example, system attendance for student, we have in our campus, we have 10,000 students. So it's important to make the training time rate as a parameter for the face recognition system. I think it will be help or get the best training time result and faster one.
Okay.
I think that's all.
Thank you so much for the answer. I hope that answer your question, yeah, Ms. Firliani. Is there any questions from the participant? Maybe there is one participant who want to ask directly to Mr. Ahmad. You can raise your hand if you want to ask directly. Okay, maybe I will ask the question for the second question, yeah, Mr. Ahmad. I see on your presentation that one of your purpose research is optimizing the algorithm to get faster result of training process and time rate of real-time face recognition with a larger data set. My question is, how long did the previous algorithm take to recognize a face? Is it according to how big the data is, or is there any criteria? Thank you.
Okay, in our state of the art, in previous research or studies, the training process of face recognition, it's already depend on the data. For example, we have in Google project, we make the Google project as a state of the art, as our state of the art. With the Google project face recognition with a million data, their training process for almost a week. The training process. So the big company like Google with their resources, with super personal computer, they also need a lot of time. Well, so what about us? Just small people like us. So in here we try modifying the algorithm, the neuron of deep learning CNN, the image dimension. At least we get the better result for the training process. I think that's all with maybe 5,000 until 10,000 face data. I think that's all, Miss Selvi.
Okay, thank you so much for your question. So it's based on the how big the data is, yeah?
Yes.
Okay, now we have one last question from
Thank
Noval.
you. Thank you.
How do you evaluate the performance of face recognition systems using machine learning and modified deep learning methods?
Okay, thank you for the question. We evaluate the result of machine learning and modified deep learning based on. Actually, we have a real-time process in our research, a real-time experiment. In our laboratorium, we put 20 until 30 students in the front of camera in a real-time condition. And for the machine learning, we get the result as using Euclidean distance approach. 27 out of 31 is recognized, 87.1% here. So we evaluate based on the data, and then the quality of the image, and also the architecture for the deep learning experiment. I think that's all.
Okay, thank you so much for the answer. I hope that's answer your question, yeah, Noval. Okay, so thank you for all your questions and comments. And thank you again, Ms. Ahmad Mahruf Firman, for your presentations. Now you can stop your share screen so we can go to the next speakers. Okay, now we go to the last presenter in our parallel sessions. Our next speaker is Ms. Firliani Rahmatianingsih from University of Indonesia, who will be presenting on milk type classification based on fat percentage utilizing deep learning and hyperspectral reflectance acquisition. So for Ms. Firliani, now you can share your screen and start your presentation. Thank you.
Test 1, 2, 3. Can you hear my voice?
Yes, I can hear your voice.
Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you for the opportunity. In this occasion, let me present me and my team research entitled Multi-Output Milk Classification based on Type and Processing Utilizing Deep Learning and Hyperspectral Acquisition System. This work are conducted by me, Firliani Rahmati NC, and my lecturer, Mr. Adi Harmoko Saputro from Universitas Indonesia. This is the outline of the presentation. The first, I'd like to explain you about introduction, about background, purpose, and state of the art. And then the second is material and method, about sample preparation, hyperspectral image, architecture and evaluation parameter, and the third is about result and discussion, and the last is conclusion. The high public awareness to apply healthy lifestyle is a fact. The importance of choosing food according to individual nutrition needs, for instance, in milk. Milk is a nutrient-rich suspension liquid food, contains various nutrients such as fat, protein, calcium, minerals, and vitamins that human needs begin from infant until elderly. According to milk products that are available in the market, the type of milk is categorized into three types. They are skim milk, low fat, and full cream. And processing coming from fresh and ultra high technology or UHT process. Therefore, we need an identification system to distinguish the milk based on fat percentage. Some traditional method widely applied to analyze the quality of milk based on nutrition contents such as electronic tongue and the sensor. And for the non-contact identification system such as spectroscopy and hyperspectral camera. Spectroscopy has the advantages, they are the accuracy, and the weakness is destructive, need much reagent and spectral data only. And hyperspectral camera has some advantages and the weakness that you can see on the screen. Recently, hyperspectral image has a potential to identification system of milk. But before we learn about hyperspectral, let's see about the advantage and the weakness for using machine learning or context sensor and the deep learning. There are advantage and the weakness that you can see in the screen. And the hyperspectral image has the easier preparation and non-destructive, quick and accurate. And about the weakness is high cost and complex in operate. Hyperspectral image is a proven method for analyzing the content of food and has been widely applied for food quality. Machine learning and deep learning methods were applied after obtaining images from hyperspectral, also developed by researchers to improve quality control systems in food. Hyperspectral imaging generates 3D hypercube, consists of two spatial dimensions, X and Y, and one spectral dimensions. Hypercube contains a lot of information such as physical characteristic of object and chemical informations. This is our architecture system for milk classification. The first is we obtain the milk sample from the market, and then we do some preparation sample of the milk. We do pre-image processing by image acquisition and image correction. In the image correction, we use some equation, the relative reflectance correction, and then we do some image segmentation. And after that, we process the image by classification, milk type classification, and milk processing classification using convolutional neural network, and has the output milk type and milk processing. This is our proposed model architecture for multi-output based on VGG16 with some modification for the feature learning or activation layers. The sample preparations, the first start begin on milk sample we obtain from the market, consists of UHT milk, goat milk, and cow milk, and then we do some adulteration milk, or we mix the milk, and then we got 100 milliliter milk poured to plastic bottle, and then sample labeling into the bottle. After that, we homogenization the milk and get the image acquisition by hyperspectral image and reflectance value obtained by using lactose LA in the faculty of Veterinary Institute Pertanian Bogor. After that, we got the data acquisition or image acquisition using hyperspectral imaging system that you can see on the screen about our preparation acquisition. Consists of hyperspectral camera, halogen lamp, Teflon, and the milk or the object of the milk. About experiment design and performance evaluation, the first we begin on the dataset, to build dataset, and we break the dataset into three categories. That's dataset validation, dataset training, and dataset testing with the composition 50%, 25%, and 25%. And then we do train the CNN model. And after that, we build a CNN model and we test the model. After that, we do some evaluation for the model that's consists of accuracy, sensitivity, precision, and specificity. After that, we got the output of our model. It's milk type, milk processing. And for this experiment, we use the computer specification AMD Ryzen 7 and GPU NVIDIA GeForce, and we use some software TensorFlow, Keras, and NumPy. And you can see the detail in the screen. About result and discussion, the first we got an original image from our hyperspectral camera, and then the second image is about image after correction, and then we do some segmentation, and based on segmentation result, we got sample of milk. We got sample of milk about the ROE. Oh, sorry. About the ROE is 9,000 images in total, and for the training, testing, and validation comparison is 50, 25, and 25%. This is the spectral features of milk that we got based on this graph. You can see that the full cream milk has the highest reflectance compared to low fat and skim, and then this the skim milk on the low fat has similar, almost similar in reflectance and the wavelengths. This is the output of the classification and of the milk and milk type and milk processing. Okay, this is for the summary of our result. For the single output of milk type, it clearly be seen that the VGG16 architecture model has the highest level of accuracy, around 98.30%, and for exception 96.09%, and for AlexNet 93.88%. Then for other parameters such as precision, sensitivity, and specificity of VGG reach the highest position of 90.47%, 91.92%, and 97.40%. And for the single output milk processing, has two classes, namely fresh milk and ultra high temperature milk. And the performance evaluation for milk processing explained that VGG16 architecture model also has the highest level of accuracy, 97.21%. And for exceptions, 95.4%, and for AlexNet, 98.89%. And this is for multi-output classification. The first is multi-output of milk type itself, and then the multi-output for milk processing model. And furthermore, the modeling was implemented for multi-output using the same three architectures and obtained VGG16 architecture has the optimum accuracy in classifying the image of milk. And the best performance was successfully obtained up to 90.78% for the level accuracy with the multi-output method. For the conclusion, we can conclude from our research that the first is the hyperspectral image system has been successfully captured and did data acquisition mix sample and identified the reflectance based on the reflectance and wavelength. For single output milk type classification, we get the best performance value by accuracy 98.30%, and for milk processing, by the accuracy 97.21%. For multi-output milk classification, obtained that VGG16 has the best performance with value accuracy 91.78% and milk processing 83.53%. And we can conclude that for milk classification based on type and processing, VGG16 proposed is the suitable architecture that provided highest accuracy. I think this is the last of our presentation, and thank you very much for your attention.
Thank you so much for Ms. Liani for your presentations. Now, for the participant who want to ask Ms. Liani, you can raise your hand or you can write it on the chat room. Is there anyone who want to ask Ms. Liani? You can raise your hand or you can write it on the chat room. Okay, maybe I will ask first, Ms. Liani. What is the accuracy measure that you use in this research to choose the best classification method? Thank you.
I'm sorry, can you repeat the question?
What is the accuracy measure that you use in this?
For the accuracy measure that we use for this model, based on this equation of based on the matrix confusion matrix, type of confusion matrix from testing for the testing data. We use the equation of accuracy that we got the data from the confusion matrix. I think is that clear?
Yes, thank you so much for your answer. Is there any question from participant? Okay. If there is no question anymore, because our time is at the end right now. So thank you so much for Ms. Liani for presenting your work. Okay, thank you. So everyone, thank you for joining us today. So that concludes our parallel session for today. Please join me in thanking our presenter for their insightful and informative presentations. After this, we have the plenary session from our third keynote from Professor Dr. Sebastian Vollmer from University of Göttingen, German at 12 until 1 p.m. So you can join the next sessions. So thank you for all participants for attending and enjoy the rest of the conference. And don't forget to fill the link for participant absence that we have shared in the chat rooms. Okay. Thank you so much for all. Okay, thank you.
Thank you, Ms. Alfie.
Thank you.
Recording stopped.